We are on the sections 9.1 and 9.7, page 36. We are going to talk about something called radicals. Okay, so let's find out what they are first, then what we are going to do with it. So, radicals are numbers. So, what does radical mean in English? It means what? A little bit crazy, a little bit unconventional, right? So we are going to learn something we call it crazy numbers. Okay? Then let's see why we call them that way. So regularly, you teach your kids to start to count by what? 1, 2, 3, and on, right? Naturally. So we call them what? Natural numbers, right? Then, when they grow a little bit older, then things are not that natural anymore. You know, so they realize, they have nothing. So when we add nothing, then we call this together. We call them what? Whole number. Whole numbers. Whole of nothing, right? Sometimes. And what's the difference between natural numbers and whole numbers? The difference is the zero. Okay, we'll give different names for it for a reason. Okay? Then later on you'll find out, besides you don't have any money or you have some money and you owe people money, right? You are in debt. Then it's opposite than having it. So it's opposite of all the positive. We add what? -3, -1, all right, negative numbers. Together, we call them integers. Okay, those are the names given to differentiate things we are using. So integers means what? You have whole numbers, positive and also negative side of it. We call them integers. But later on, you find out, oops, besides the whole thing, I might just want to eat half of a pie or 1/3 of a pizza, right? So you might have, say, decimals and fractions, right? We put it together. We call them what? Are they all reasonable to you? Very easy to connect, right? Comprehend. So it's a reasonable, we call them what? Rational numbers. Okay, so rational numbers including what? Positive and negative and whole numbers and fractions. So fractions are still very reasonable and comprehensible, right? Then what do you think? Beyond reasonable, rational means reasonable, right? Beyond reasonable, what do you think? We will call them? We call them what? Irrational, right? Irrational numbers. So irrational numbers are those numbers a little bit crazy, right? So irrational, some number like a pi, because it's a decimal, 3.14159, forever going, never ending for the decimal points, right? So, and something like a square root of 7, square root of 2, all that. Then all those irrational numbers in the crazy way, those things, we call them what? Crazy numbers, radical numbers. Okay, so we are here. We are going to talk about how they are, you know, from and why. However, those are numbers. Okay, so numbers like this. And if you have one here, right? Then we wonder, one here, one here. Then we wonder how long is this number on the side, right? So how do we see it? So it's a little bit longer than the 1, but less than 2. And it's not quite a good number, okay? So those numbers not exact, a little bit crazy, then, but is that real? If you have this is a real thing, right? You can see it. So, however, so we put this together, we call them what? Real numbers. Okay? So real numbers including those both crazy one and rational one. Okay? Beyond real will be what? Unreal thing. Unreal numbers. So we call them what? Imaginary numbers. They are not real, but imaginary, right? So start from I, so we use I. Then you will learn this in your pre-calculus class. So those are the numbers mainly we deal with, okay, in your algebra and pre-calc. So we also learned, okay, this one. Basic skills we are learning for the fractions, right? For the fractions, for rational numbers, for positive, negative, whole number, and fractions. What kind of things we learn? The basic skills we have learned. We learn for fractions. We learn how to simplify them. Simplifying, right? Adding, subtracting, and multiplying and dividing, right? So we also learn what? For polynomials, what do we learn? We learn the same thing, simplifying, add, subtract, multiply, and dividing. Okay? Then for rational expressions, what are rational expressions? Do you still remember? It's a polynomials in fraction forms with bunch of letters, right? From last chapter. What do we learn? We're still learning what? How to add them up, add, subtract, multiply, divide, right? So that's what we have been learning for the basic skills. Same thing for the radicals, for the crazy numbers, we will still learn all this, right? For radicals. We are going to show you how to add, subtract, multiply, and divide, and simplify all those crazy things. Okay? Then we say, after we learn all the basic skills, simplify, add, subtract, multiply, and divide, right? Then what do? We will solve equations, right? That's the process we have been doing. After we know how to solve equations, we will what? Solve problems, like solve word problems, right? Then we change the English words to the equation, then we solve it, right? As polynomials or quadratic equations we have been learning, right? Then ideally, that's the science part of it. Then we will solve what? We will hopefully solve world problems, right? That's our learning process for the math, okay? So then let's talk about what kind of things actually those are. All right, so when we introduce those crazy things, radicals, it looks like this symbol. Okay, then we describe how we look at these symbols and what do they mean, the concepts. Then we do the operations, right? Okay, so before we do that, then let's describe. Okay, so what's the opposite of addition? Subtraction. Opposite of subtraction, addition. Opposite of multiplication would be what? Division to each other, right? Another thing is opposite is exponents, okay? And radicals are opposites. Then let's see what do we mean by that, okay? They are in concepts. They are doing the reversing about each other, okay? So let's see. For radicals, we also call them roots. What do we mean by that? Okay, so if 1 squared would be what? 1, right? 2 squared would be 2, right? Oh, no. Never mind. 3 squared would be what? 9, right? So 4 squared would be what? 16. So for the exponent, then this is the base to the power, that's the result, right? Then opposite, here we'll give you a base with the square power, second power, then you have a result. Now we wanted to do this way. If I give you a result, find your base, okay? So what if we ask you, what is the square root of square, because we take a square, right? We want to find out square root of 1 is what? That's what we want to find out, okay? So for instance, 4 squared is 16. Then how about negative 4 squared? It's also 16, right? So we ask you, we will tell you, we say 4 and negative 4 both are what? The root of the 16, the square root. Square root means what? The root of square, right? So we say 4 and negative 4 both are square roots of 16, right? So we are doing opposite. So from the result, we find the base, the root, cause that square things to happen, okay? So instead of doing exponents, we go back to find the roots. Where are they from? Okay, if 2/3, that would be what? 8, right? If negative 2/3, negative 2 to the third power would be what? Negative 8, right? So we'll say what? 2 is what kind of root? What kind of root of 8? It's a third power, right? So we say it is what? Cube root of 8. Because you take a cube, you get 8. Okay, we trace back what is the root. Okay, then we say -2 is what? It's a cube root of -8. Okay, so first we introduce to you is what? The exponents and the roots are opposite to each other. One thing, you take powers, exponents, then you find the result. Another one is you have a result, you go back to find your roots. Okay? And the symbol used is this way. Okay? We use things like this. Right? So, if on the bottom, okay, you can see if I've squared the 0 means what? What number? So this is the number. What number take a square, right, would be the result 0. So which number is that? That would be 0. Right? So we use this symbol means square root of 1 means what? What number here, right? What number? You take a square, become 1. That's 1. Right? So square root of 4 would be what? Which number take a square, become 4? That would be 2. Right? Then square root of 9 would be what? 3. Square root of 14, not 14, 16. Would be what? 4. Because this number, right, 4, take a square would be what? The result. Okay? When we use this is the square root. Sometimes if it's cube, then we take cube root. Okay? Then this guy, this symbol, we call it what? Radical symbol. This guy, we call it radical symbol. Okay? This one we call it index. So like this one is 2, invisible 2, right? If cube roots, then that would be 3. Fourth root means something take 4 times would be the number inside, okay? Then inside this number, we call it what? Radicand. That's the name. All right. Then if the n is what? Our number, then we say we find the what? Our roots. Right? Then if n is even number, then we are going to find the what? Even roots. Right? Okay. So when we write this way, all right, we thought, okay, just like we say, what's the root of square for 16? If we ask you, what are the square roots of 16? What's your answer? The answer will be, the answer will be 4 and -4, right? However, if we use this symbol, square root of 16, we only write a 4 because this symbol, square root symbol, only represent the idea of the positive root. Okay, because that's the symbol used for, right? If we say, okay, what's the square root of 64? right? Then your answer will be what? 8 and negative 8, right? However, if you write the square root of 64 with this style, then we only use what? 8. Only use the positive one. Then we call this one what? Principal root. Okay? And if we write it this way, what happens? If we write it square root of negative 64, what do you think? It means the root of what? Negative 64, anything multiplied twice will be negative 64. If 3 times 3, that would be 9. If negative 3 times negative 3, negative number, multiplied twice, still positive. Anything multiplied twice, okay, it will not be a negative. Okay? So, if the inside the radicand is a negative number, right? The root doesn't exist. So this one doesn't exist. Or you can say doesn't exist, or you say not a real number. The reason we say not a real number is because we have fake one for it, okay? But we are not going to cover it for now. So just to let you know. So actually, negative square root of negative 6, we will say what? It doesn't exist. Okay? And so, we want you to use the calculator as well. So you practice, okay? Figure out. If you have questions, then we can go over. And it's hard to show here. So, let's do evaluate first. So, 4th root of 16, that's a positive, right? So, what kind of answer you will give? Some number multiply itself 4 times is 16, right? It's 2. Or you can do the trees. Then you find out, oh yeah, 4 of them, right? So, you can do that. Okay? Then, if 4th root of negative 16, what do you think? Anything multiplied 4 times? No way, right? Will be positive. Same thing. As long as if it's even number, inside of the even root, it has to be positive. If it's negative, it doesn't exist. If you have this one, negative square 4th root of 16, what do you think? Negative is outside, attaches to the number behind it, right? This number is 2, so you attach, that's how you do negative 2. That's the square root or 4th root, right? Even root. So inside the even root, you cannot have negative number. However, how about cube root, R root? We can do that, right? So if we have a negative 27, what do you think? It would be negative 3, right? Because negative 3 times 3 times is negative 27. Or you can write it this way. If it's a negative, you can take a negative. If it's a cube or R roots, if it's negative inside, you can take it out. Just like that. You will end up what? Same thing, right? That's 4, 5, 6. And if we have negative cube root of 27, that will be 3. Maybe 3. They are the same, right? So, if we have this thing, can we do it for fractions? Yes, same thing, right? That's 5 squared, that's 9 squared. So that will be 5 nines, right? Because 5 nines times twice, it will end up 25 over 81, right? Same thing, we can do it for the decimals. So that would be 0.8. Still remember how do you do your decimals? 0.8 times 0.8, so your 8 times 8, 64. How many decimal points do you need? 1 and 2, total will be 2. So that's how you do it, right? And if we have this one, 8 over 125 cube root. So you do it separately. The cube root of 8 is 2, 125 is 5. So you times it 3 times, you will end up this way. Okay? We also want you to look at the calculators, okay, to do those. So those are good numbers. Multiply twice, you have good number. What happened to square root of 2? Use calculator, figure out, all right? And you can see there is a square root there. So you should get what? You need to practice this. Will be 1.414 something. Because square root 2 should be what? Between 1 and 4. 2 is between 1 and 4, right? So your result should be between 1 and 2. 1.414 something. If your square root of 3, it should still be between 1 and 4. 3 is between 1 and 4. So the result is between 1 and 2. It's like this. Make sure you get it. Otherwise, call me. Right? And let's see. If we have square root of 5, square root of 6, square root of 7. 5, 6, 7. Okay, and 8. Actually between 4 and 9. Right? So those numbers should be between 2 and 3. Okay? Then you should get 2.236. Okay? Then this number square root of 6 should be what? 2.449 something. Square root of 7, you should get 2.645 something. Okay? Make sure you figure out. Otherwise, you can even go online and go to the website, say, okay, or Google it, say, you know, how do I use calculator to do the square root? You might even have a YouTube to explain to you, to show you. Okay? Let's look at the next page. We are on the page 38. So, first we introduce the idea and the symbols, how we use those symbols and what do they mean, right? So radicals are what? The opposite of the exponents. Cube root means opposite of the cube. Square roots means what? The opposite of the squares. Okay? Then we will apply the same thing for the variables as well. Let's see how we are going to do it. Okay? So if I have 2 to the square is what? 4, 3 square is 9, 4 square is 16, right? Then its opposite will be what? The root of 4, square root of 4, right? What's the root of square? That will be the base. Okay? Then we have square root of 9 will be what? 3. Square root of 16 will be what? 4. Right? Then same thing, if I have x, take square will be what? X squared, the result. Then we do the opposite, find the roots. Okay, so what's the square root of x squared? That would be this guy inside the root, right? If I take x squared to the square, that would be what? Fourth power. Power on power, you multiply your power, right? So this one would be what? For the fourth, take a square root, that would be what? That guy, this guy, right? X squared. If I have x third to the square, what do I have? 6, right? If I go back to find the root of square, that would be the root. So that would be what? X cubed, right? So what do we want to do? Actually, you just divide by 2. That would be 1 divided by 4 by 2. Go into 4, that would be 2. Divided 6 by 2, that would be 3, right? So all you have to do is just divide by 2. Then you get it if you take a square root, right? Or if you look at the x 8th power, you divide it by 2, that would be what? 4. Right? Another way you can look at it is we wanted to find the root of the square. Then if you look at this one, x 8th, that would be how many x's we have? 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, right? When you want to take a square root, that means every square you take a root out. Every square you take a root out. So for this square, if you take out, then you get rid of the square root, right? That would be x. For this one, that would be x. For 2 of them, that would be x. For this 2, that would be x. So total would be what? 4 of them. You can look at this way as well. Like 6 of them, every 2 of them, then you have 3 pairs, right? 3 twins, each one show the root. You have 3 of them, becomes what? X cubed. Okay, so that's a square root. Then, how about the cube roots? If you have the cubes, all right, cube roots would be what? Opposite of the cubes, right? So, if I have x1 take cube, that would be x cubed, right? Then if I want to find the root of cube, I should get this. So I have x cubed, I should take cube root. That would be what? The root. That would be x, right? So if I have a square, take a cube, I will have what? x6. Then if I want to take cube root of 6, so which one is my root? Then that will be what? X squared, right? So x cubed to the cube, power on power, you multiply, right? Then what do we have? If I take x 9th power, take a cube root, I should get the root. That one, x cubed, right? So what do? We just divide it by 3, right? As well. So it's the same thing as divided by 3, right? Your power. Another way to look at it is what? If you have 9 of them, right? 9 of them. When you take a cube root, then every what? Triplet, then you have to show the root, right? For the triplet, the root will be what? The root of cube. Cube, the root is x, right? Then this one is what? Another x. This one is what? Another x. So when you multiply together, you have x cubed if you do it individually, right? So it's the same thing, 9 divided by 3, you end up this way. So to take a cube root, what do? You can divide the exponent by the 3, right? So if we have cube root of y of 18th power, what do you think? Every 3 of them you show a root, right? Then how many 3s? they are. So 18 divided by 3, 6 of them, right? 6 triplets. So each one is a rule of y, 6 of them. So you have y6. That's how you do it. So what are we doing? We find the simple one, the root of something, cube roots or square roots. Okay? But sometimes we will have leftover. Then we show you how to manage that. Okay? Otherwise, you can just divide 9 by 3. It's 3. 6 divided by 3 is 2, right? Just by dividing the 3. Because every 3 of them, you take a root out. Then you find out how many triplets they are. That's how you will manage it. Okay? If we have 36 power, find the square root. What do you think? How many twins there are? Every 2 of them. That's why 36 divided by 2 of them. So it's what? X 18th, right? Because you have 18 of those twins. Okay? So if you have cube root of x 36, what do you think? How many triplets? 36 divided by 3, so that's x 12, right? If you have x 36 for the fourth root, quadruples. So what do you think? How many fourths together? 9 of them, right? 36 divided by 4, so that's x to the 9th power. Then if we have this one, cube root of 64 x to the 3rd power, what do you think? Number with numbers, variables with variables. So 64, you do your trees, you find out it's 4 times 3 times, it's 64. Then x, triplet, it's just x as a root, right? If you have 5th power of a negative number, 30x 10th, y 5th. Can we do it for the negative number with r power? Right? For the r root, not r power, sorry. So it's r root for negative 32, that would be negative 2 times itself 5 times. Then for x 10th, that would be x squared, right? Divided by 5. Then y 5th would be just 1. Right? So we just simply introduce what? The radicals concept, right? The roots. Radicals means taking roots. Square roots, cube roots, fourth roots, fifth roots, all that. Okay? Then we just make it simpler as such. Then we will do simplifying next time. Okay? Next section. So we just introduce the symbols first and the concepts behind it. So another thing we want to mention is something called radical functions. So functions, we use symbol function. Okay, x is what? A radical expression. So we say expression is the algebra language. We use expression, right? Just like polynomials are expressions for math. Okay, so we might write it this way. Okay, let's show the example first. F of x equals this. Okay, another one we use g of x equals this cube root. Why we use x, f, and g? Actually, it means what? Those are y's. Okay, but the y is getting from x to y, from A to B, point A to point B, right? So from x, with this style, we go to y, find out what's the y value. And it's a function, so we start from f. We just follow alphabetical order. Sometimes we use what f, sometimes we use g or h. We just follow through to differentiate, one from another, just different symbols, but they mean pretty much the similar concept. Okay? Another thing we learned from functions early on, we talk about its domain and range. Domain, something called domain, something called range. Okay? Let's just, the terms we use. Domain means what? Domain means all possible x value. Okay, then range is what? All possible y values. Okay, you don't see how actually why we have to learn that until you go to higher math. Okay, into pre-calc, calculus. Right now, we just introduce the terms we are using. Okay, so usually we go from x to y, from point A to point B, we will go to from domain to the range. Okay, from x to y. Then because that's x is where you start, right? It's your domain. Domain means or your territory or your x value you will apply it to. Okay, that's where you start. You don't go beyond your domain. Okay, that's what I mean. So we want you to identify, okay, when I use the radical expression or radical function, all right, this one is a radical expression, but we write f in front of it. We call this one is what? A radical function. They are the same, but we just use different symbols, right? Radical expressions only has what? X in it. Radical functions we are talking about is the guy y. Where you get it to actually is the range, the result of this. Then domain is only the x guy. Okay? Then expression, after you expressed, then that would be your y guy. Okay, that's the symbols we are using. What do they mean for? All right, just for now, for you to follow through. Okay, so radicals and fractions, they have something different we use because they have restrictions. Like fractions, the restrictions will be what? We did it in the rational expression. Like this one, fractions, right? X cannot be 0, right? So the domain x, when you do it plotted, so when you do x, y, t tables, then you can put the x as any number, but you cannot use 0, right? Because it's restricted. Same thing when we use radical functions, it has restrictions sometimes. Why? Did we just talk about for the odd roots and the even roots, right? If it's even roots, the inside of the even roots cannot be what? Negative number, right? You can use 0, 1, 2, 3, but you cannot use negative number because it doesn't exist for the y. So your domain will be restricted. So this one means what? Inside has to be bigger or greater than 0, right? So that means x and minus y has to be bigger than 0. Then how do you write your answer for the restriction for x? You will do x and describe it. So you will put a bar there. That's a formal symbol of math, right? So what happened? X has to be what? Bigger than, bigger than or equal to 4. So we put it into curly bracket. Okay, all those are formal symbols of math. Then that's how you describe your restriction of X. X cannot be less than 4. Okay, cannot be 3, because 3 minus 4, -1, cannot be 0, that's -4. We cannot do that. Okay, so that would be the domain. If we ask you what is f of 8, what does that mean? It means what? 8 is where you started, x. Then you get to y. Y is your f of x. Okay? When you get from 8 to where? Then you plug in, right? So you will get what? Square root of 4. That would be 2. That would be your answer. Then range is your f. That's your destination. Then inside 8 is your starting point. Okay? If you have f of 6, what should you have? You plug in 6 to it. Doing it is easy, but you have to understand the meaning of the symbols before you can actually know what you are doing while you plug in certain way. Then 6 minus 4 is 2, square root 2. Then that's 1.414 something. But for the accuracy, we just leave us a crazy number. We call them what? Radicals. Right? Then for this one, another function. Okay? So it's a cube root, R roots. So there's no restriction inside. You can use positive, negative, fractions, decimals, right? Zeros, all right. So you can plug in x for anything. So your domain is what? All real numbers. You can use any number, okay? If we have g of -1, what do you mean by that? Okay, that means I start from -1. Where do I go to? Y. So my x is -1. You plug in -1 plus 2. That would be cube root of 1. That would be 1. Okay, so you go from -1, go to 1. If you have a 1, you start from 1. Where do you go to? So you do cube root of 1 plus 2 is what? Cube root of 3. It's not a good number. It's a crazy number. We just leave as is. Okay? Then, if we have, say, this one is not on your paper. So if I have g, say, -10, what do you do? Just plug in -10. Then what do you have? That's what I mean. You go from -10, where do you get to? Get to y, right? So that would be what? Cube root of -8. That would be -2. That would be your answer for that. Okay? So we just start to introduce something called radicals. That will be our sections 9.1 and 9.7.